Hello everyone, welcome to today's class. Today we are going to start a new topic under trigonometry, and that would be multiple and submultiple angles. So here I have the formulas for multiple angles first of all, and secondly I'll show you the submultiple angles as well. So we have already completed quadrant rule, compound angles, transformation. Okay, all these formulas that we have done earlier are equally important for this topic as well. So let's start with the formulas. The first formula in multiple angle, highlight multiple. So multiple angle means more than actually higher angles. Actually we also call it double angle or triple angle. Okay, multiple angles, or we better call it double angle formula. We can also say it double angle formula. Why double angle? Because instead of theta there would be 2 theta in these formulas. Okay, there will be 2 theta. Or triple angle formulas, here we also have triple angle formulas. We can also say triple angle formulas, correct? Okay, as well as we'll have half angle formulas on the other side. So here as you see, submultiple angles or half angle formulas. Here we call submultiple formulas. Because the theta has been made into theta by 2, correct? I'll show you the relationship between these two. It's a very easy formula. So let's start with the first formula. The first formula here we have is a sine 2 theta. The formula for sine 2 theta is 2 sine theta cos theta. You need to remember this formula, 2 sine theta cos theta, very basic formula. The second one is cos 2 theta. Cos 2 theta is given by cos square theta minus sine square theta. Very similar to the identity. Identity is cos square theta plus sine square theta. Here it is cos square theta minus sine square theta. And if you replace sine by cos, just to show you an idea, if you replace this sine by cos, so let me show you here, cos square theta minus if you replace sine square theta by 1 minus cos square theta, check it out, then you will get cos square theta minus 1 plus cos square theta, and that will give you 2 cos square theta minus 1. Check this out. So this is the formula. Just simplifying the upper one, I get the lower formula, this one, correct? And similarly, if you simplify with sine square theta, then you will also get the lower one. Let me show you. You have cos square theta minus sine square theta. If I replace this by sine square theta, 1 minus sine square theta minus sine square theta, then you will get 1 minus 2 sine square theta, correct? So it is alphabetically placed if you want to remember the sequence. Since cos c comes first, so 2 cos square theta minus 1, okay, it is in the right hand side. You may say it's just in front, and the s comes later, so you may have to write sine later. If you are confused, this is what I am saying actually. If you are confused about 2 cos square theta minus 1 and 1 minus 2 sine square theta, if you are confused about which one comes earlier between these two in the formula, then just remember the alphabetical order. Cos always comes first. Okay, 2 cos square theta minus 1 is the correct sequence of writing it, and 1 minus 2 sine square theta is the correct sequence. Okay, 2 sine square theta minus 1 is not correct because sine doesn't come earlier, it comes later. Are you understanding? That's how we try to remember the formula. Okay, that's how I remember the formula. Now, having understood the sine 2 theta and cos 2 theta formulas, I can frame 3 more formulas from 2 more formulas, actually 2 to 3 formulas, yeah, from these formulas. How? Check this out. These are the ones actually. So we know, let me write it down here. We know, let me write a little clearer. We know cos 2 theta equals to 1 minus 2 sine square theta. That was the formula, isn't it, everyone? Yes, check this out. Here right in the beginning, this is the formula I'm talking about. If this is the formula, then I can frame the formula for sine square theta. Transpose 2 sine square theta equals to 1 minus cos theta, 2 theta, sorry, 1 minus cos, I have to write 2 theta. And then what can I do is sine square theta will be 1 minus cos 2 theta divided by 2. Can I do that? So this is the first formula. So check this out. This is the one that I have to theta. These are all thetas, by the way. These are thetas and theta. So this is the first formula where I just change the subject of the formula. I just transpose here and there, and from the cos 2 theta formula I will get another formula that's for sine square theta. Did you understand, everyone? This is the 10th one. Similarly for cos also I can do, because cos 2 theta equals to 2 cos square theta minus 1. And then from here I can do 1 plus cos 2 theta divided by 2 equals to cos square theta. I hope you have understood. 1 is coming this side, correct? 1 comes this side, and same formula is formed. But if I divide these two now, if I divide sine square theta by cos square theta, I'll get the 11th formula, and that will be tan square theta equals to 1 minus cos 2 theta divided by 1 plus cos 2 theta. So till now we have learned 5 formulas. The first two here highlighted in blue, and the other ones also I'll highlight it. These formulas which has been formed by just transposing the first formula that I have learned. Correct? Now I have to I have another set, and that set is again sine 2 theta, cos 2 theta, tan 2 theta, but now in terms of tan theta. And this is the one: sine 2 theta equals to 2 tan theta, 1 plus tan square theta. Cos 2 theta equals to 1 minus tan square theta, 1 plus tan square theta. And tan 2 theta equals to 2 tan theta divided by 1 minus tan square theta. You can form tan by just dividing these two actually. Okay, so just remember sine cos, and then you will have the formula for tan 2 theta. Now you may say there are so many formulas, isn't it? Actually, this first formula, if you see here, this is sine 2 theta in terms of sine cos, but this one is sine 2 theta in terms of tan. So you may have to use in different sense sometimes the formula. Okay, so you may have to convert sine 2 theta in terms of tan theta, then you will use accordingly the lower formula. So there are many formulas here. Try to understand these formulas, try to copy and remember this. Okay, and now based on this only, now we will also learn submultiple angles. Let me show you this side, submultiple angles. Now the same thing, submultiple angles, or we also call it half angle formula. Now how do you remember this? Actually, the submultiple formulas are exactly the same as multiple formulas, but it has been made half. The angle has been made half. Okay, we have reduced the angle. How it is done? Check this out. What was sine 2 theta? Sine 2 theta was 2 sine theta cos theta. Let's check it out this side, isn't it everyone? Sine 2 theta was equals to 2 sine theta cos theta. Check it out. What did I do? This 2 theta has been halved. That means this has become, if you divide 2 theta by 2, then you'll get theta, and all the other angles also halved. So theta by 2 cos theta by 2. Check this out. You have halved the angle. That's why it's called half angle formula. Check this out. Same formula, the angles have been halved. There was sine 2 theta, there is now only theta. Cos 2 theta, only theta. And all the other angles has been halved. So that's how we call it a half angle formula. And then same sequence here also. So you need to copy all these formulas as well. Similarly, the formulas for sine square theta, 1 minus cos theta, 1 plus cos theta, that's for cos square theta. And for tan theta also you have the formula. And then in terms of tan theta by 2 also you have all three formulas. Same thing, if you write side by side, you will understand this properly. So did you understand? So these are the multiple and the submultiple angles. Okay, the formula for multiple and submultiple angles. Let me what I want you to do is you just copy the formula in this way. Okay everyone, I would suggest you copy the formula like this. What you do is you just make 2 columns, and then you copy the formula in this way. Then it will be better for you to understand. Let me show you how. Write your multiple write your multiple angle, or you may write it as double angle, and on the other side submultiple angle. Submultiple means half, or angle, you just write on half angle, correct? And let me just show you a few examples. How do you write? First one is sine 2 theta equals to 2 sine theta by 2 cos theta by, 2 sine theta cos theta. Now same thing, how to make it half? This side, sine theta, just make all the angles half. Angles has to be halved. These angles, 3 angles. Okay, sine theta, if you have 2 theta, you'll get theta. Half means divide by 2. Divide all the angles by 2. Then 2 sine theta by 2 cos theta by 2. See, all the angles has been halved, correct? Then number 2, cos 2 theta. The formula was cos square theta minus sine square theta. That was the one. And then here I'll write cos theta. That's cos square theta by 2 sine square theta by 2. I have halved all the angles. Here it will be 2 sine square theta minus 1. Here you'll get 2 sine square theta by 2 minus 1. Just half it. Here you will get 1 minus 2. My mistake, sorry, there's a small mistake here. 2 cos square, in fact, theta minus 1, 2 cos square theta by 2 minus 1. That's the correct sequence. Cos comes first. 1 minus 2 sine square theta, and then here 1 minus 2 sine square theta by 2. Okay, and the third one, similarly you'll get sine square theta equals to 1 minus cos 2 theta divided by 2, and sine square theta by 2 will be 1 minus cos theta by 2. See, all the angles I've halved, just half the angle. Check this out. Theta, theta by 2. 2 theta, 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 theta by 2, theta, theta by 2, theta, theta by 2, theta, theta by 2, 2 theta and theta. Did you understand? Just half the angle on the other side. Then the fourth one would be cos square theta, that will be equals to 1 plus cos 2 theta divided by 2. That's the normal formula. Multiple. How to make it half? Cos square theta by 2, half the angle, and then you'll get 1 minus cos theta divided by 2. Similarly, the fifth one, tan square theta will be 1 minus cos 2 theta divided by 1 plus cos 2 theta. And then if you half it, you'll get tan square theta by 2. That will be 1 minus cos theta divided by 1 plus cos theta. So this is how you just make it normal angle into half angle. Check this out. The blue dots are the normal and the half angle that you have converted. Okay. Do you understand? All the angles on the left first were normal. On the right, you just made all the angles into half angle formulas. Got it? And then the sixth one now, sine 2 theta. 2 theta, that's equals to 2 tan theta divided by 1 plus tan square theta. How to make it half? Sine theta only. That will be 2 tan theta by 2 divided by 1 plus tan square theta by 2. And similarly, the seventh one, cos 2 theta, that will be 1 minus tan square theta divided by 1 plus tan square theta. As I copy, you also copy this formula, and cos theta equals to 1 minus tan square theta by 2 and 1 plus tan square theta by 2. That's how you make it half, correct? And finally, the last one, tan 2 theta, that's 2 tan theta divided by 1 minus tan square theta. Make it half. Tan theta equals to 2 tan theta by 2 and divided by 1 minus tan square theta by 2. So these are the 8 formulas that we have discussed. On the left, you have written multiple ones. On the right, you have written submultiple ones. The formulas, the sequence are exactly the same. Only the difference is in the angles. Okay. So this is how I want you to write the formulas and understand it. So as I have explained here also, I'll just post this formulas, attach these formulas below. You just copy this, correct? And after we have done half angle, now we come to a triple angle. There are triple angle formulas also. Okay, you write this down separately. And triple angle would mean 3 thetas. So the triple angle formula, only 3 we have. That's sine 3 theta. That's 3 sine theta minus 4 sine cube theta. And cos 3 theta, 4 cos cube theta minus 3 cos theta. And this is for tan 3 theta, just in case you need it. 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. I remember the sine 3 theta by, remember this sequence, 343. Check this out. 300, okay, let me show you. 343. See the sequence? That's how it is written. And cos theta, the sequence is 433. Remember, as soon as 4 comes, the next number would be 3 and it will be in the power. Okay, so find your own ways to remember this. That's how we remember the formulas for all this. Okay, I know there are a lot of formulas in multiple and submultiple angles, but these are in fact very important. Okay, and these formulas will be used to simplify trigonometric identities now. Okay, some more trigonometric identities will solve here. Okay, proving the left equals to right, same type of sums will be solving here. And very often questions come from multiple and submultiple angle. This is the most important exercise in trigonometry. Okay, so please copy the formulas properly. Okay, here we have some examples, some sums based on multiple and submultiple formulas. Let us see the first one. Prove that sine theta plus sine 2 theta divided by 1 plus cos theta plus cos 2 theta equals to tan theta. So here we are solving identities with the help of multiple and submultiple angles. So probably we will also be using some formulas that we know from earlier, maybe compound angle formulas, maybe some trigonometrical identities we have learned from class 10. All those formulas are helpful, including the submultiple and the multiple formulas that we have learned. Okay, so let us start the left hand side. From the left hand side, it says sine theta plus sine 2 theta divided by 1 plus cos theta plus cos 2 theta. Earlier you will not be able to solve, you would not have been able to solve this sum because you don't know the formula of 2 theta, double angle formula. Now since you know it, you can just put the formula and solve the sum. So I have sine theta plus, what's the formula of sine 2 theta? Everyone knows. Let me write it down here. Sine 2 theta equals to 2 sine theta cos theta, if you remember it, isn't it everyone? So let's replace 2 sine theta cos theta. Great. Now comes denominator 1 plus cos theta. And what is the formula of cos 2 theta now? Cos 2 theta equals to, let me write down, cos square theta minus sine square theta. Check out the formula. Is that correct, everyone? Okay. Then what can I do is I'll replace it here. Cos square theta minus sine square theta. Okay. In fact, now there's a small problem actually. There were 3 formulas of cos 2 theta. Let me rub this and show you. There were actually how many formulas for cos 2 theta? Cos 2 theta, there were 3 formulas. One was cos square theta minus sine square theta, if you remember it. The other one was 2 cos square theta minus 1. And the third one was 1 minus 2 sine square theta. Actually, if you know how to simplify, you can use any of these formulas. But which one will be apt if you want to see here? Then you have to, if you want to choose the appropriate formula, then you have to be careful. Okay, if you use the appropriate formula, then the sum will be a little shorter. Otherwise, simplifying using any of the 3 formula is also okay, provided you know how to simplify and not get confused in between. Okay, so now what can I do here is let me take out sine common in the numerator. Sine theta common in the numerator. So sine theta, and I have 1 plus cos theta, correct, divided by 1 plus cos theta. Check this out. Plus, now here what happens is cos square theta minus, I'll have to replace sine by cos, 1 minus cos square theta. Correct? Okay, you may say, sir, instead of doing this, why can't we replace directly the formula here? Why can't we directly use 2 cos square theta minus 1 here? That would be correct, absolutely. Actually, if you do that, this will be perfect. Okay, because using the appropriate formula will make the sum easier. Now this will by the way, there is a 2 here, my mistake, because sine is out, and the 1 and the 1 gets cancelled here, and then the denominator becomes, let me show you, cos theta plus 2 cos square theta. Can I take out cos theta common in the denominator? Check this out. Yes, because there's a cos theta common. Let me do that. Cos theta common, and I get 1 plus 2 cos theta, and then the cos theta, the bracket gets cancelled, same thing, and this will ultimately give me sine theta by cos theta, and that's equals to how much, everyone? Tan theta. Correct? So this is how we solve this sum, proving the left hand equals to right hand side using trigonometrical identities as well as the multiple and submultiple formulas that we know. Now again, I'm repeating this. You had the option of replacing cos 2 theta as any of these 3 formulas, 1, 2, 3. Okay, but I preferred using this because using this would make my sum easier. 1 and 1 gets cancelled, and clearly cos theta will become common. I could have used the upper one as well. As I showed you, it will become like this: 1 plus cos 2 theta plus cos square theta minus sine square theta. But that way, what I'll have to do is I'll have to convert this sine square theta to cos square theta by using the identity. So cos square theta and then minus 1 minus cos square theta. Ultimately, you would get the same thing, because check this out: 1 plus cos theta plus cos square theta minus 1 plus cos square theta. So 1 and 1 gets cancelled. Ultimately, you are getting cos theta plus 2 cos square theta, which we got just by cancelling. Okay, so it's the same thing using the formula, but it will make the sum lengthier. Choosing appropriate formula is up to you now. Okay, if you choose the appropriate formula, your sum will become shorter. If you don't choose the appropriate one, then you may have to do little extra steps. Okay, great. So having done that, now let me rub this, and let's come to the other sum that I have here, the other one, and that's here. Cos 4 theta, prove that. This is also proving sum. Let me write it down here. Prove that cos 4 theta equals to 1 minus 8 sine square theta plus 8 sine to the power 4 theta. This is in the power, by the way, 4 theta. Let's start this sum. I'll start again by writing the left hand side, that is cos 4 theta. I don't have a formula of cos 4 theta, but I have a formula of cos 2 theta. And that you already know. There are how many formulas for cos 2 theta, by the way? Let me write it a little this side. The formula for cos 2 theta is cos square theta minus sine square theta. That's the first variant. Sorry, the other variant is 2 cos square theta minus 1. The third variant is 1 minus 2 sine square theta. Okay, all the three variants you have here. So you can use any one of this, whichever is appropriate. Now let's make a 4 theta into cos 2 into 2 theta. Can I do that? Because now it looks like cos 2 theta. 2 theta acts as theta now. Are you getting the point, everyone? Check this out. So it might be a little confusing. This red circle acts as theta. Doesn't it look like cos 2 and theta? Now theta stands for 2 theta here. Okay, so now what can I do is I can use the appropriate formula, and the appropriate formula I prefer would be, though everything here on the left, right, is in terms of sine, I would prefer using cos in the beginning, because ultimately in the end cos has to be converted to sine. Okay, so let's try it out. Let's see. If it doesn't work, we will change our way of replacing the formula. We can use then sine, okay, instead of cos. So I will use 2 cos square theta minus 1, but theta is 2 theta. Can I do that? Interesting. Okay, now I can write 2 cos 2 theta. Can I write the square outside and then minus 1? Okay, preferable. That gives me now 2. Again the formula of cos 2 theta. Now ultimately I'll write in terms of sine. Okay, I'll write it in terms of sine, because that's the last change now. Now 1 minus 2 sine square theta whole square minus 1, correct? This gives me 2 open bracket a minus b whole square. That will be a square minus 2ab, check this out, and then plus b square and minus 1, and ultimately close the bracket. Okay, that gives me 2 box bracket open 1 minus 4 sine square theta plus 4 sine to the power 4 theta, and then bracket close minus 1. Do you agree with this, everyone? Check this out. How? Because 2 into 1 into 2 is 4 and sine square theta, and 2 square is 4 and sine square theta whole square is sine to the power 4 theta. You know it. A square of square will give me a to the power 4. That's the properties of indices. The powers will multiply, correct? That gives me 2 minus 8 sine square theta, careful, plus 8 sine to the power 4 theta minus 1. 2 minus 1 ultimately will become 1. So 1 minus 8 sine square theta plus 8 sine 4 theta. And that's what I was supposed to prove. Check it out. Absolutely. So you can write here, hence proved. Okay, so see this one more time. What did I do? I preferred cos in the beginning, and then ultimately I changed cos to sine. So you can also try using other formulas, the other variants, and see whether you will get the same answer or not. But this would be the easiest way to prove this sum. So did you understand? So this much for today. I will give you a few homeworks to try. Please try those sums by using multiple and submultiple angles. Thank you.